I am P.K. Mohanta, Professor, IARE, Telangana, Hyderabad. So, all are welcome to the class, again the aerodynamics, and we are going to discuss on the same potential flow. We are going to, some components and new things we are going to discuss. And if we will discuss about it, how it will be, let us hope we will talk about the uniform flow. What is the psi and phi value of uniform flow? That means everywhere we will talk hereafter only the psi and phi values. The flow, that means there are uniform flow, and that uniform flow may be parallel to x-axis, parallel to y-axis, and it may be an inclined flow. These are the three different type of flows are possible, right? So if three different flows are possible means first we will talk about the parallel to x-axis. That means in case we will take a coordinate system, that is y is the o is the origin and x is the one axis and y is another axis. So in case flow is coming in a parallel to x-axis, we can say this is the uniform flow parallel to OX axis and coming from left to right. That means it is a positive, right? That we have to consider the positive. Then in case there is also a chance that we can show the velocity may come parallel to OY axis, right? OY axis. In that case, what will happen? The same thing you consider the same axis and flow is coming in this direction. But we call, when it is parallel to OX axis, we call it is a U. And parallel to Y axis means we call the component is V. Okay, these are the two things you remember. But when in case the flow is at constant velocity at any direction, we cannot give guarantee that always it will be parallel to x or y, but it may be in any direction. In the any direction, if we look at, that means in direction we will take means that time it will have a resultant velocity. We can say this is the q. Okay, that in case we will take a q, obviously it will have a two components. If that is the resultant, then q is the resultant, then it will have the two components u and v. So how we are going to talk about this? This we are going to discuss on today's discussion. Uniform flow, that is the constant velocity parallel to OX axis from left to right. From left to right means it is a positive, right? So that means first let us consider only this. Then what will be its psi value and phi value? So we have to think about that. So if we will talk it, that means let us try to understand what is the meaning of it, or from the understanding, this is the pictorially presented, same thing is narrated in a sentence wise. Let us consider now the stream passed the coordinate axis OX and OY at the velocity u, which is parallel to OX axis. The same thing is represented in the figure right. By definition, the stream function psi at the point P. So you assume that, so take any arbitrary point, need not be there. It may be here, anywhere you take it, an arbitrary point you take it. And in that flow is given by an amount of the fluid crossing at any line between O and P. Between O and P, between O and P, that means how much, that means if we will join how much amount of the fluid crossing, that is it will give us the value of psi. Same way, for the convenience contours, the O, T and P. That means for this, if we will consider the 2 points, which is right vertically down on the axis X, that's when the OTP. So that means it is easy for us to simplify. That's why we are talking about this. For convenience, the contour OTP is taken where T is on O axis, on axis A and on O, and T is given by the OX. We have given like a Some notations we have given. So let us talk about the first stream function. How the stream function will be there? The stream function psi. That means stream function psi we can write, that is the flow crossing the line OTP. OTP. How much flow is crossing? That means that is equal to how much? That means flow crossing on the line OT plus flow crossing the line of TP. That means now that is our basic understanding. This and this both are same, right? It will say how much flow is crossing in the OT, because since it is parallel to it, parallel to the x-axis. So OT, any flow is coming like this? Anything? No. It is no fluid is crossing the line of OX or the OT line. Okay, so that will be equal to our 0. And how much is the fluid or flow crossing across the TP? That depends on the where is the P, that the length of the TP. Either you assume this length is my TP is equal to this length is equal to X. So it will be U into X, or that is the length of TP or the length of TP. So we can write how much is that length. This is not the X, this is the our Y axis. So let us consider this is a Y. Okay, so that means 0 plus U into Y. So psi value is therefore it will be equal to how much the psi value when the in a uniform flow parallel to x axis, that is equivalent to psi is equal to Uy. That is nice for stream function. What about the velocity potential? So let us consider the velocity potential. The flow, how the velocity potential we know it? The flow along the contour OTP. Flow along the contour OTP. This is across. You see that word is very important. Across, and this is along. So this is the difference. You should be very, very careful. Okay, that the flow along the OT, and flow along the TP. If you will take it, flow along the OT, how much flow is coming? That is this velocity we have considered is U into X, plus along Y any velocity is going? No. Along this, no flow is going. So obviously that is 0. So if we will add it, phi is equal to Ux. So now these parameters I am going to use in few slides. Okay, so that one will be interesting, and you should remember that psi and phi value for the uniform flow parallel to x-axis. Similarly, uniform flow when we will take parallel to OY axis. The OY axis, if we will take it, that means the flow is coming like this, like that, from bottom to up. Okay, so the stream function psi at a point P x y, you assume that any point which coordinate is x and y, the flow is given by the amount of the fluid passing the curve between O and P, right? We have seen it that it is irrespective of the path, whatever it may be, the way we will take that. Whether we have seen that in the very second slide, the second lectures, we have seen it how it is different. So for this OTP, again you consider OTP. We will consider OTP. OTP we will take, and then we will say same. We will say what will be our stream function. Stream function is flow across the OT, plus the flow on this line, right? Along the across the TP, across this we have to consider. So how much is flowing on OT? Flow flowing along OT is equal, it is a V, right? Here we have not considered U. It is a velocity, the y component, we have taken this one as a v. So v into x, how much is the distance? This distance is nothing but our x. So this distance is velocity into x. If we will consider it is far up, it will having the more flow. So it is distance between the origin to the point where you are considering, plus the flow across the our T and P, the point. That is, no flow is crossing on that line. So it is equal to 0. So psi value will be your minus Vx. Okay. Similarly, we will take now the our velocity potentials is equal to flow along the OT. You see the word again, across and along. You should, I am repeating it again and again because we should not do the mistakes. Okay, the flow along the OT is the flow along the TP. These two if we will add, we will get it totally. Along the OT anything is crossing? Obviously no, it is nothing is crossing. So obviously that will be 0. And along how much the TP is going? All the are going along in that direction only. That is V into X, V into Y. Okay, along that. That means V into Y. So this is the way, this is another way we do it. Uniform flow parallel to OX, OY. We have done it. So let us see in a particular angle it comes, what happens. That will be probably one of the most interesting part. Uniform flow of constant velocity at a given direction. If there is some angle is there. If angle is 0, that means either it is parallel to x or parallel to y, right? So based on the angle only it depends. So we will try a general case. Now consider the flow streaming past the x, y axis at some velocity q. That means some velocity q means this is my resultant velocity making an angle of theta with OX with reference to x-axis. We are taking that angle we are measuring, and the velocity means this velocity is the resultant velocity can be resolved into the two components u and v, that is parallel to y-axis and v will be the parallel to y-axis, that is respectively. So therefore we know it, q square is equal to u square plus v square from the normal triangle resolving the triangle like that. Okay, and what will be the tan theta, that is the angle between them, tan theta is equal to v by u, right? That is the angle we are making. So how it will be look like? Basically these are fine, but if we look like, if the flow is coming like this, or in the x and y coordinate systems, when it comes parallel, when it becomes the resultant, it can be resolved into the two parts, u parallel to x-axis and v parallel to y-axis, right? And q is the resultant one, right? And this is my o. And so obviously this angle is the theta. This angle is the theta. So when this angle is theta, so now we will see what will be its psi value and phi value. When we talk about the stream function, that is the value of psi, that means flow crossing L on OT. That means if we will consider a point here, how much is flow crossing on this? That means if we will take another point T, how much this plus this, if we will add it, we will get the total. Therefore, why we are taking the negative sign? It is coming from it is resolved like the V is upward, right? So component of Q parallel to, or maybe read out again. Therefore, the flow across the TP, flow across OT, that means O to T. If you consider a point P here, then this is the T and this is P. What will happen in this case? Flow across OT, flow across TP. If we will consider, obviously you see here in this case, some flow are crossing in this direction also, right? Some are crossing in here also it is crossing. both axes it is proceed. So in this case, we will take that is the component of Q parallel to the OX is X and plus the component of Q parallel to the OX is Y. In this way, if we will consider the psi value we will get it minus Vx plus Uy. Same way, if we will consider now the what will be the our velocity potentials, velocity potential will be sorry, the velocity potentials will be phi equal to flow along the OT and plus flow along the TP. If we will add it, that is same way the phi will be equal to Ux plus Vy. So therefore we know it that phi will be equal to Ux plus Vy. Why I asked about or I emphasized this on this uniform flow, because this uniform flow can be, it may pass over the cylinder, it may pass over the aerofoil, it may pass over anywhere this one. So what will be the stream function and velocity potential at that? That's why I emphasize more on today's in these presentations. Okay, so let us look and for this, and thank you very much to all of you attending this class, and all are welcome. You can reach me by my WhatsApp number is given 9500145037, or you can reach me in both email ID prasanta.mohanta@gmail.com. This is my personal mail ID, but I prefer you should reach me on m.prasantakumar@iare.ac.in. I prefer this because this is my official mail ID. Okay, thank you very much for attending the class.
Like, share and subscribe. Hit the bell icon for more updates.